Good afternoon or good morning, everyone. This is John Foley with the Safer Buildings Coalition, and thank you for joining. We'll be starting our webinar at the top of the hour, which is in about 3 minutes. So please stand by, and we look forward to today's presentation. Your lines are all muted. If you're having any technical difficulties, you may use the chat window to alert us to any problems with audio or video. We look forward to starting at the top of the hour. We're going to close the mic now and open it back up at 1 o'clock Eastern Time. Hi, this is the Safer Buildings Coalition webinar series, The Life Cycle of a Public Safety Network. Good afternoon and welcome, or good morning if you're in a different time zone. We're glad that you're here. We'll have an interesting program today featuring Alex Jovell, Manager of Sales Engineering from iBwave, and Scott Pollister, Director of Business Development from C-Squared. A couple of points before we get started. Your audio is, your microphones are muted, but you can communicate to us through the chat window if you're having any technical problems with audio or the slide presentation. This presentation is being recorded and will be available for replay later. You'll receive a follow-up email with information about that link. At the end of the session, I will be conducting a question and answer session with Scott and Alex with questions that were submitted during registration. But you can always follow up with us afterwards for additional questions if something comes up during the session. And let's go to the next slide, and we'll introduce the Safer Buildings Coalition. So the Safer Buildings Coalition is a not-for-profit trade association who's interested in all manner of in-building communications when there's an emergency. It's important that people be able to dial 911, be accurately located, and remain in contact throughout an emergency, and that first responders also be able to remain in communication throughout. We provide a lot of resources through our web portal, and even more resources and benefits to our members. And you can visit us at saferbuildings.org. And go to the next slide, please. So the agenda for today, we'll start with C-Square Systems. C-Squared is an integrator and maintenance and monitoring provider based in the Northeast of the United States. They'll cover defining the need, technology basics, some integration tasks, and then finish up with maintenance and monitoring. And then iBwave will go into some of the tools that are available for design and making sure that these systems are installed correctly, the different tools that are available. And the idea here is to talk about, from start to finish, everything that happens from conceptual phase to ongoing day 2 maintenance after a system is installed. We'll have key takeaways, and then at the end we'll do a conversation. I'll be asking some questions of Scott and Alex. So with that, let's get started. I'd like to introduce Scott Pollister, excuse me, from C-Squared Systems. Next slide, please. And Scott, take it away.
Great. Thank you, John, for that introduction, and thanks for the Safer Buildings Coalition for putting this together and creating this webinar. I think it'll be a great event. I also want to thank iBwave for hosting on their service. So hopefully everybody enjoys the webinar. So from my perspective, as John mentioned, what I'm going to go over is quickly the need for the communication systems, some technical basics, as well as the deployment process, and which would include a typical deployment process, high level, which would also include maintenance and monitoring. Just quickly from my perspective, for my company, I work, as John mentioned, for C-Squared Systems. We're a system integrator primarily in the Northeast. We do perform services across the country. So we've been around and were founded back in 1999. So we've been in the industry for quite a while. We help our clients manage and expand communication networks, basically, and we do that through a host of services and offerings, including radio frequency services in general, which also include in-building wireless as well as wireless LAN, or 802.11, whatever, as well as software development. So we have software tools that we provide specifically around monitoring and maintenance. Next slide, please. So I think, so my presentation, I want to start off with, I always think it's a good idea to start with defining the problem. And this is probably obvious to a good number of the people attending the webinar, but I think it's always good just to paint the picture and make sure everyone's on the same page, at least from the way I see it. So I think you can notice, and what most people will agree with is that radio signals are have limited propagation through various materials, and that's why it's hard to cover. And that's the case for the concrete metal buildings, the low E glass, as well as underground. So in all these areas, your coverage inside those buildings is limited just because RF doesn't propagate well inside those buildings. And so that's the first part of the problem. The second part of the problem is that, or to add to that, there's a high percentage of 911 calls that originate from cell phones indoors specifically. And so there's almost two problems here. There's the people indoors trying to make cell phone calls to call for emergency help, but also there's also the first responders, fire police chief, and the emergency responders that are in a building and trying to use their communication systems, which is a different set of, and we'll go over this, which is a different set of technologies and a different set of radios and frequencies, and we'll go over that. It's also interesting to find out, I saw a recent survey that also shows that many of the first responders actually also use their smartphones while on the job. So there's a dual purpose there. But basically what it comes down to is not only do you need public safety enhancements within these buildings and underground and other areas where you don't have good coverage, but you also need cellular coverage, again, for people to be able to call and reach out for help to get those services. Next slide, please. So just to help paint the picture of the order of magnitude of this, I found these statistics. I thought they were somewhat interesting and helps, again, give an order of magnitude to it. These are call statistics from the U.S. Department of Transportation back in 2017. So they published statistics for 2015 and 2016, which showed the number of 911 calls that were made via different methods, so wireline, cellular, VoIP, text to 911. So these different methods that made 911 calls, and then how many of them happened within the 2 years, within the year of 2015 and 2016. You can clearly see, so I added on top of this sort of the percentages so you can see the order of magnitude. Clearly, there's over 80% of these calls are now coming from cellular, and this was back in 2016, so we're now in 2019, so I can't imagine how much more this has grown. So you can just see that there's a number of calls that people are placing to 911 from cellular devices, and there's a lot of other statistics that tell you that most phone calls from cell phones are originated from indoors. So again, these calls are being made from indoors, from cell phones, trying to reach out to get help. There's also another statistic, I didn't put it on here, but I recently saw, I looked for, didn't find anything I wanted to put on a slide, but the International Association of Fire Chiefs, I saw, I did a survey back in 2017 that said, within, they surveyed them and said within the last 2 years, how many buildings, percentage of time that you encountered a building with communication failures, and it was up to 56% over the last 2 years. So again, it's from both sides, it's a problem. Next slide, please. So even though it's a similar problem, what I wanted to point out through this presentation is some of the differences between cellular and public safety. While it's the same problem and you're using similar equipment to solve the problem, and sometimes you can actually use the same DAS that you're going to deploy, there are differences between the two, and it's good to understand those. So I'll run through some of these, and just at the top, the purpose of the cellular deployment would be to meet the carrier's standards, their signal strength, their signal quality measurements. Whereas on the public safety side, the same goal is to meet the codes that the AHJ has adopted for that municipality. So that's sort of the difference. Clearly, there's a technical difference in terms of frequency bands. So on the cellular side, there are many bands that need to be covered for each of the licenses the carriers, the wireless operators owns, and that could be 600, 700, the real traditional cellular 850, PCS, EW, I mean, it goes on and on. So there's a number of bands. On the public safety side, there's also a number of bands that need to be covered. It could be UHF, VHF, they have 700, 800. So there's, and I probably am missing something. So there's a number of bands even on the public safety side. But the thing to point out here is that they're different bands. They intermix. In other words, there's some in between each of them, but they're different. The cellular side, it's more capacity and coverage driven. On the public safety side, it's coverage only driven. There's not really capacity for public safety. There's no need for capacity, or typically not for public safety. For coverage objectives on the cellular side, you're typically looking, your primary goal is to cover offices and meeting rooms and production areas, so that high traffic areas. On the public safety side, it's actually more important that you make sure you're covering the fire pump rooms and the exit stairs and the elevators and things that, places where in emergency people are either getting out, or the fire department or emergency responders are congregating to make decisions and make calls. So, there are different coverage objectives. And there's difference in, cellular is higher density requirement versus lower density for public safety. The monitoring is different. Monitoring is typically, for the cellular side, is typically done by the wireless operator's NOC or by a third-party maintenance vendor. Whereas on the public safety side, many of the code requirements for each of the municipalities say that there's a dedicated fire panel, and the information needs to go to that fire panel and then ultimately to the fire department. The equipment on the cellular side is more standard and available. Sometimes on the public safety side, it can be custom and longer lead times. So again, there's a number of differences here between them, but you're solving the same problem and typically or can be using the same equipment. Next slide, please. So on this next slide, what I wanted to just kind of go through in the next part of my presentation is to quickly go through what is a typical deployment, what does it look like, and while I'm doing that, I'm going to try to point out some of the differences between the two methodologies in terms of cellular deployment and public safety. So it all starts with defining the requirements. So that's always the first step. So is the public safety system needed? Contact your AHJ, the fire police, and understand what are the requirements. You want to gather all the information that's required. So our frequencies and channels need to be covered, the coverage goals, are there any existing systems or RF sources? So gather all that information. Understand the other parts of the code requirements. There's other code requirements that say, that dictate battery backups, enclosures, again, coverage requirements. So you want to start with gathering all that information. And then a next step for typical deployment is to potentially go on site and not only test the existing coverage from the outside to verify you do need a system indoors, but also to test and classify the building. So you're setting up, temporary transmitters and measuring wall losses and things of that nature within the facility that you're designing, because each facility is going to be different. Hospital is certainly different than a warehouse. So you do this, and if the building isn't existing, if it's planned, if it's a new building, you do your best to simulate this, and hopefully you've had a lot of experience doing this. So you simulate it using tools like iBwave, and then you also confirm with measurements as when you can, when there's enough of the facility built and constructed. The last part of this is to take that data that you've gathered and all the requirements and then make sure you come up with a good model tuning process, and that you have a good model so that you can simulate coverage throughout the entire facility. So these are all the first step of sort of the development process, or the deployment process. Next slide, please. So what I was attempting to do here in this slide is to sort of illustrate a little bit the differences between a block diagram of public safety deployments versus the cellular deployments, and how they could be mixed together, and how that changes based on a small venue versus a large venue. So that was sort of the attempt here. And so let me go through this quickly and try to use this slide to explain that. So at the top is your smaller system, and then at the bottom of the slide is a larger system. So at the top, your systems are typically BDA or repeater, so broadband amplifier. So it's either that. Typically in smaller systems, I know cellular, we don't tend to deploy cellular BDAs anymore. So that's just more of a requirement from the cellular companies. They tend to deploy more small cells that are connected directly to your high-speed internet access. So In this case, again, in small systems, those are over-the-air fed repeaters. On the public safety side, especially for the VHF frequencies, if you're transmit and receive frequencies, if you don't have sufficient channel separation, you're looking at having separate transmits to receive. Or the cellular side, you're not. But both of these systems are covered by BDA. They're typically, almost in all cases, separate BDAs, obviously. So that's small. As you move to and they're all coax based, there's no fiber. As you move to a larger building, you may be talking about a common fiber distributed in system. And this also depends on, a lot of this depends on frequencies. So in the public safety side, if you're looking to cover more, the frequencies required are more of your 700, 800, 900 bands, then it makes a little bit more sense to include that on the public safety system. You also need to take into account, for any of these steps, the requirements from the AHJ and from the local municipality, because in some cases, some municipalities don't allow the systems to be on the same DAS. I think I saw a survey recently that ZenWave did in conjunction with the Safer Buildings Coalitions, where it was of the public safety community that they surveyed, I think 19% reported that they permitted combined systems. So it's actually a pretty small percentage. But anyways, the other thing to mention at the larger side of this is that you may have a fiber system out to a number of remotes. On the cellular side, you're deploying more remotes for higher density, higher coverage. Or at the public safety side, you may not deploy public safety at each one of those remote locations because you don't need as much capacity, and the coverage is probably easier to achieve at those lower frequency bands. So there are definitely some differences and some commonalities between the two. Next slide, please. Ultimately, on this next slide, what the engineers are doing as they're putting together this design, they're using the tool. This is actually an output from iBwave, where you're looking at all the gains and losses over the entire path from the system all the way down to the end user, and then also in the reverse direction in the uplink. So you both have to take into account the uplink and the downlink. And so you use tools like iBwave to do that, and they have a great tool that helps someone, an integrator or designer, someone that's trained, someone that's certified, to be able to put together these designs, because it takes into account things like free space pass loss and all your splitter and cable losses and wall penetrations. It helps you look at interference and signal strength and coverage areas. So you'd use this to calculate coverage from your amplifier all the way out to your antennas to make sure you're meeting the coverage requirements. Next slide, please. So after you've done the design, the next part of the procedure is to look at install, commissioning, and testing. Again, you want to make sure you contact your AHJ to understand what the requirements are. Most of it includes all installation to be done in NEMA 4. Other things for installation likely include being a licensed electrical contractor, being either certified by the AHJ or the state, certainly being certified by the factory trained for the BDA or for the equipment you're installing. So there's a number of installation requirements. On the testing side, you want to make sure I look at it, there's 3 testing phases. There's the initial system commissioning, where before you do the official, what they call grid test, or however the test is defined, you may want to look at it from just a spec A kind of point of view and look at just signal strength. When you're doing the grid test, the acceptance testing, what you're typically using is a radio from the fire department or like model, and you're measuring not only signal strength according to this grid test, but in most cases the requirements say you want to measure the DAQ level, and so you want to get a level of 3.4, and they have ratings on the DAQ level based on audio, being able to understand the audio, and so you'd be testing that, and you'd test it in each one of these grids essentially. And then the last part of testing is annual testing, where you have to go look at visual inspection, but also battery. Does the battery still performing sufficiently? Does it have some minimum that's defined? Is the donor antenna still secure? So there's a number of things you want to look at.
Hey Scott, this is John.
Sure.
Would you mind just for a second explaining what the acronym DAQ stands for and you know, kind of how that works?
Sure. Yeah. So the DAQ stands for the delivered audio quality. So again, that's a ranking that they've came up with that says when you're doing this test, you know, signal strength is important, but it's not the most important. Actually, what's most important is, you know, even though your signal strength is good, maybe your quality isn't good. And so DAQ is an attempt to sort of measure that. So the delivered audio quality is ranked from a 1 to a 5, and a 1 is basically unusable speech or unrecognizable, whereas a 5 is perfect. And so I think most requirements, and John, correct me if I'm wrong, most requirements are defined around a 3.4. It's either 3 or 3.4, I can't remember, which is basically speech is understandable without repetition and there's only some noise or some distortion. I think that's how it's defined. But that's what DAQ is.
Thank you.
Yep. Next slide, please. So the next step after you've commissioned, installed, and tested this system, you need to really think about maintenance and monitoring. Again, NFPA 1221 defines system monitoring requirements. NFPA is not necessarily what all the municipalities have, so I always caution people to say, you know, certainly understand NFPA 1221, but that's where most of the municipalities copy their code from, right? Or they use it as when they're developing their local code. But it's always important for any new project to understand what the actual municipality has and what the AHJ is requiring. And so in most cases, but in most cases, what they're doing is they're almost copying it, or copying it most of the substance, because it is actually good code. Again, so things you wanted to make sure that's typically listed is you wanted to monitor your AC power and loss of normal AC power, your active emitting devices, so your BDA, your repeater, you make sure you want to monitor that. Low battery, you know, at 70%, battery charger fail, donor antenna fail, system component failure, and then also the communication link between, you know, this device that's capturing those, which is the annunciator panel, essentially where those lights show up, right, to the fire panel to make sure that communication isn't broken. So NFPA defines this. Again, most municipalities adopt it as is. More proactively, you know, one of the things I talk to people about, and I make sure people understand, is that, you know, you may want to go above and beyond that, and because there's a lot of things that could happen that can impact coverage and resulting in your communication. Beyond that, those could be things like your input and output power. So even though your BDA is still online and your donor antenna is still connected, maybe your power levels dropped. And if your power levels drop, then your coverage in your building's probably dropped. So if you're not monitoring that, you know, all your lights are green, but when someone goes there, they're not going to be able to make a phone call. You may want to, for the larger systems, you may want to look at fiber loss. Is the fiber loss to the point where it's almost failing? It's still working, but it could be failing. So, you know, understanding that. Alarms on parameter changes. So there's a number of parameters on these devices that need to be set in order for the system to operate. So did someone change those that impacted coverage? So you can change your gain levels, and that would change your coverage. Again, all these things that aren't required to be monitored in most code, they could affect the coverage. The other is outside events, where are you monitoring your heating and cooling for the environment that these things are in? If not, what if the equipment overheats or starting to get too hot and will overheat and fail soon? So there's a number of things that I consider more proactive approach, and I really think that they're important for ensuring safe communications, reliable safe communications. Next slide, please. So this is just kind of a continuation. Again, the last slide in terms of monitoring. So you deploy these systems, and you know your options are to make sure you have reliable services. You know, you can wait for the customers or tenants, employees to complain. So in other words, you're not monitoring, you just wait for them to call you and say, hey, this isn't working. You could walk the floors upon completion and make sure you're compliant, and do that every now and again. Again, that's time consuming, and sometimes that's needed on an annual or quarterly basis. But I think the real answer, in my mind, from efficiency and reliability standpoint, is to monitor things. Monitor those RF levels, put probes in important locations to monitor user experiences, and then, you know, organize your information. Next slide, please. So just in summary, this is my last slide. Some of the lessons that we've learned by doing a number of these over the years has been you want to make sure you work closely with your venue owners and AHJs to ensure you have the requirements and the goals understood. Public safety and cellular data systems need to be treated separately. Not necessarily physically, because again, sometimes you're allowed and sometimes it makes sense to combine them, but you want to make sure you understand the requirements, differences between the two, and understand the motivation behind both. Design the system with maintenance in mind. What I mean by that is when you design a system, make sure you're putting equipment as best you can in places where you can get to it and maintain it and take care of it. So if you need to get to a remote, an amplifier, you don't put it someplace where it's hard to get to. Test the system with proper equipment to make sure everything's working correct. And then proactive monitoring is another key piece of this, which I talked about before, where you may want to go above and beyond the minimum requirements. The last thing that I had here was just to, I'm a big fan of Clay Christensen and sort of the famous Harvard Business School professor, and he has this jobs to be done framework. I know that framework, it's basically understanding. It's not just, hey, I need a public safety system or I need a cellular system. It's really understanding what the real job to be done here is. And the job to be done is for these types of systems, that people want to be able to communicate effectively and reliably for all stakeholders in emergency situations. So it may be more than one of those pieces than the other. And you want to make sure that when you're looking at these deployments that you're considering the entire job to be done. I think that's all I had. I'll answer questions as they come up. Thank you.
Thank you, Scott. Excellent job, and a nice segue into the next section. So that's a great overview. And we had a question that come up, what does AHJ stand for? We'll try to be mindful of alphabet soup. Authority having jurisdiction. So an authority having jurisdiction could be a local inspector or fire code official, and they're the ones that have the power to grant a certificate of occupancy in a building. They're the ones that are enforcing the fire code that's on the book. And the fire codes that are relevant in the United States are the NFPA codes 72 and 1221 that relate specifically to this issue, and in the International Fire Code in section 510. So let's go to the next section. If we'll go to the next slide, I'd like to introduce Alex Jovel, who's the Manager of Sales Engineering for iBwave. Alex, take the mic.
Hello, everybody, and thanks for the introduction there, John. My name is, like you mentioned, is Alex. I'm part of the sales engineering team here at iBwave. I have over 15 years of experience in RF, including in the past working for Tier 1 operators and OEMs that specialize in creating hardware for public safety. So I recall even back in those days, we used to create specialized filters because there was a carrier operating an 850 that would interfere on the SMR 800. So that's a little bit of my background. As far as who iBwave is a software solutions company for the design, documentation, and deployment of in-building wireless and wireline networks. We make software for desktop PCs, servers, and mobile devices such as tablets and smartphones. And we are trusted by over 1,000 customers and presence in more than 100 countries. So today's agenda, what I wanted to cover is talk a little bit about the solutions that we have for public safety, and then dig a little bit more. We talked a little bit about NFPA, IFC standards, so a little bit of the RF part on that and how you would use our solution to analyze that. So a little bit now I'll go into what we offer our solution. So we're known, for generating heat maps, but the reality is that we have, especially in today's day and era, right, when we have sometimes awful events remind us of the importance of or the need for having a good and building coverage, is that we have a whole full set of solutions that will help on the full life cycle. So from that initial RF testing that Scott was mentioning to obviously making your detailed design, the submittal, to helping with the installation and commissioning, and finally with acceptance testing. So what I wanted to do real quick is to talk about the different solutions that we have. So we have, like I said, a whole set of solutions to help out on the full life cycle. What we have also is a solution called Unity that you see here on the left-hand side. And what this is a management platform. So imagine a location where you could store all your public safety projects, right? Or a central location where you could view project information or store, for example, all the grid testing that you did. Or it's also something very useful, especially if we have to do yearly tests and we need to reference some of the projects. Well, you have it all in a central location. The focus of today is going to be a little bit on iBwave design. So that's a little bit of our flagship product, what we have here in the middle. And this is a solution that helps with the design of, any kind of band that you could think of related to public safety. So UHF, SMR 800, BAM 14. So we have a way of importing floor plans and, generating to see, especially if you don't want to over-design or under-design, especially in this cases, right? And we have different modules for that. So it comes with a prediction, a propagation module, optimization, and collection. And the other thing that I wanted to mention is we do have a different flavor of this called iBwave Design Lite, which is not as heavy as our enterprise version, but is a good starting point for somebody that wants to get started with our solution. And finally, what we have is a solution called iBwave Mobile, and this is an Android-based platform that could help, for example, annotate equipment rooms, emergency exits, important stairwells, right? Scott mentioned a little bit of the differences that you would do when doing a design for public safety versus cellular. And also the good thing about this solution is that we integrate seamlessly with solutions such as PCTEL that could help out with things for commissioning, grid testing that Scott mentioned earlier. So that's a little bit on the solutions that we have. I did also want to mention that we do have a free version called iBwave Viewer. So this is a perfect tool for ASJ, project managers, and it allows you, imagine it as a PDF viewer, right? So you have an iBwave file. Obviously, you can't make changes or generate heat maps or anything like that, but it at least allows you to visualize your design plan, output maps, compliancy results, and it's free, right? So this is also something very handy available for the public safety community. Okay, the next thing that I wanted to cover was a little bit of the RF guidelines. So usually when we're doing any kind of design, we reference NFPA or IFC standards. And in there, you'll find different type of information, such as things for battery backup, etc. What I did want to focus a little bit more was on the signal strength. So if you look at the signal strength, usually you'll see that a reference to -95 dBm, and it's a general requirement to cover at least 90% of the general area, or 99% of that kind of coverage in critical areas. So critical areas would be emergency exits, stairwells, etc. And if you think about dBm, it's if you wanted to correlate it to the signal bars that you see on your phone, that's a little bit of what the reference would be there. So you see the table there, -98. So that's roughly around what how you could correlate this dBm value. So now that we have a good reference, the other thing that I wanted to cover is how you see this in our software. So from that, I'm going to go ahead and open up our software real quick. And what I did, our software, obviously Scott mentioned we have a training certification. I know a lot of the folks there at C2 have that available. But what we do is we have, obviously when we're doing any kind of in-building design, the first thing we're going to use is we're going to import some kind of a floor plan. So I use the software to generate a quick, simple BDA design. So this is our design plan. This is what that view that Scott was mentioning earlier. So we could see real quick, the donor antenna and the feed into each of the additional floors. So I did something really simple. What I wanted to highlight a little bit is on the compliancy, right? So we mentioned -95 and 95% of the general areas. And the good thing about our software is we could create different heat maps. And when we're creating the heat maps on here, we have an option of entering this compliancy, right? So if you see here, I entered that -95 value in 95% of our area. So really quickly, when I generate this heat map, if I zoom in here a little bit so we could see it a little bit better, you'll see that in the legend, it'll tell us whether we're achieving this metric or not. Not only that, but we could turn on legends to see, for example, material. And I just generated a quick, heat map on signal strength. If I recall correctly, I think, John, in one of the meetings you had, there was people asking, well, we want to see bleed through outside of the building. So there's other predictions that we could generate. I just wanted to focus on this presentation on signal strength. But as you could see, not only do we really get a quick view on this, but we could also view all of this in 3D. So it gives it a good visibility into that, and the software, for example, will take the losses in between floors into consideration. The other thing that I did on my design here is that if I go ahead and turn this off, is that I identify the couple of the critical areas, right? So I'd identify my emergency exit, I identify this control room as something that's important. Obviously, this area where I have my equipment and the lobby area, so and what we could do is we could also generate a heat map for that area and view it if we want also in 3D. And as you could see for this critical area, what we did here, if we look at the legend, we could see really quickly, well, if you see here on here, we could enter that compliance value. So in here, we enter that -95. In the critical areas, we want 90% coverage. And we're easily able to see it in the software. So the software is useful to help with that. It's also, so this would be, for example, something useful that we could see whether our VDA is, NEMA 4 enclosure, or if we have all the appropriate parts available for our design. The other report, for example, that you could see on here is the compliance report. So this, you could see that we have a report available whether we reach that critical criteria that we set for the critical areas and the general areas. So that's a really quick overview on some of the stuff that you could do and see in our software. So it's very, like I said, pretty simple on my end. The key takeaways that I wanted to say for my part, on our part here, is that, obviously, especially with the events, having in-building coverage is critical for public safety and very important. I often get surprised when people are making important decisions based on PDF, right? So very important that you use the tools that are out there to help you validate that you are meeting NFPA and IFC requirements. And then finally, the other thing that we wanted to mention real quick is that we're going to be present at the IWCE conference. So feel free to stop by if there's any questions regarding that. And I know we're also going to be part of a panel there that John is also going to be part of. So, and that's it for my part.
Thank you, Alex. Good job. Can we go back to the IWCE conference slide, please? Thank you. And as you can see, the International Wireless Communication Expo conference is in Las Vegas. It's from March 4th through 8th. The exhibit show is between the 6th and 7th. And exhibiting passes are pretty inexpensive. They're even less expensive if you have a discount code from one of your favorite vendors, or if you're a Safer Buildings Coalition member. iBwave will be exhibiting in booth 3244. C² will be exhibiting in booth 3044, and the Safer Buildings Coalition will be exhibiting this year in booth 3751. The session that goes from 8:30 to 11:30 a.m. on Tuesday morning is going to have 3 separate 1-hour panels. They should be very interesting. So we look forward to seeing you there. So with that, let's go back to the title slide. And I'm going to go through some of the questions that were submitted during registration. And just a couple of quick housekeeping items. First of all, a copy of the presentation will be made, and all registrants will get a copy of the presentation by PDF afterwards. So I probably should have said that at the top of the presentation, you don't have to snap pictures of the screen. With the audio, yes. So there's a webinar recording that'll include the audio as well as the screens will be made available. You'll get a copy of that. And with that, let's move on to some questions. So the first question I wanted to ask is to Alex. Someone submitted a question about future technologies. Alex, so for future technologies like 5G or CBRS, are there plans for the software to take those kinds of technologies into consideration?
So John, yeah, thanks for the question. We already support CBRS. I know CBRS, at least some of the case studies that we've seen, there's like private networks, et cetera. What I would like to say about that is not something to replace anything, right? It's going to be like another toolkit available for engineers. So a couple of years ago, when there was a lot of hype around small cells, everybody was saying that it was going to replace DAS, right? At the end of the day, it's another set of toolkits that we have available for us. In the case for CBRS, there were a couple of OEMs that were pretty aggressive with their CBRS plans. So we've been supporting that for a couple of years now.
Okay. And then we had another question that came in was, does the software show possible antenna-to-antenna interference? And I guess you could expand on that, because it could be service antenna to service antenna or service antenna to donor antenna isolation, those kinds of things. Are they modeled by the software?
So we could generate, SINAR heat maps on our software. I know from our side also we're looking at public safety a little bit closer to see what kind of additions we need to add to our software to better address the segment. And one of those things, for example, is that isolation, right, between a donor and your donor and your signal antenna. So there's still some things that we could probably add, and we're always willing to listen, to especially the community. But there are already a couple of heat maps that we could use to generate and see that kind of interference. And the other thing I would also like to mention, especially with band 14, right, and LTE, I'm pretty sure there's going to be other KPIs besides signal strength, right, that would address things like SINAR interference, et cetera.
Thank you. So you mentioned band class 14, and for those not familiar, that is the band that is allocated to FirstNet, which is the first broadband public safety network. It's a federal agency. The network is being built by AT&T. And one of the concerns is how close band 14 is to other pre-existing cellular bands in the 700 space. Scott, as an integrator, that kind of interference between cellular and public safety, how do you watch out for that? And if you encounter it, what do you do about it?
Sure. So yeah, you definitely want to be careful with interference. And as we mentioned a little bit at the beginning of the presentation, public safety in some cases isn't standard out of the box. You may need to put in specialized filtering and other mechanisms to prevent interference from public safety to cellular or the reverse, essentially, right? So it is a case-by-case basis, and I think you really need to understand that and look at the requirements of the system, and when you're doing the design, make sure you take that into consideration. So I think, that's how we do it, and you just need to make sure that whoever's doing the design understands the requirements and understands what can go wrong if they're not paying attention to potential interference.
So one of the things that can happen if a system were to get into a loop or runaway mode is, or when they start to what they call cascade, is it can actually shut down the radio network out in the real world. And a poorly designed and installed system down in Florida actually did that. And it took them a couple of weeks to find the offending system. And so they've written into the fire code that if they locate a system like that, they require you to shut it off. And this includes cellular systems. So these things do need to be professionally installed and maintained. And speaking of maintained, it does mention in the fire code in IFC 510 ongoing monitoring and a need to take corrective action if there's a fault. So some of those, how are those? How do you integrate the in-building wireless system alarms back to the fire alarm systems so that whoever it is that's watching that, whether it be the central office or whoever, how do you make those connections, Scott?
Sure. Yeah, I can try to address that to some extent. So, you're right. I think the code requires monitoring of these systems, and they're very specific. I went through some of the requirements. They're very specific in terms of monitoring AC power, antenna, donor antenna fault, battery. Is the BDA still operating? So there's some very specific requirements in most local code. So what you want to make sure you do is, so there's a couple answers to this. One is most codes require what they call an annunciator panel, right? Which is basically a panel that illustrates and has LEDs on it, right? That are green and red. That basically says, okay, is AC power all right? Is system power, is the antenna okay? Is the amplifier okay? Battery charger? Right? These green and red lights, and those are connected through various sensors, and to test, for instance, the donor antenna, you may need to install bias tees to make sure you have a circuit that it basically tests the circuit to make sure it's not shorted and not in fault. But you'd also have a way you'd have a sensor for the battery to test the voltage over time. So you tie all these things back into the annunciator panel, and so they sell. So there are manufacturers that have like a DAS alert, have boxes that you can acquire for systems that don't have this. The other part to this answer is that there are a number of manufacturers, BDA manufacturers and DAS manufacturers, that are including this into their equipment specifically. So they're creating equipment that meets the requirements for a lot of the NFPA code. So you don't need a separate annunciator box or panel. You can use the equipment specifically, and then with the other part to that is then it has to be tied into the fire panel, typically via the dry contacts, and then that's also part of the alarming. Is you need to make sure that that communication between where you're collecting these alarms, this annunciator panel, and the fire panel, that communication isn't in fault. So you have to be able to test that as well. So all of these things. So that's the initial requirement. The other piece to this is if you want remote access and to be able to do some of this more proactive monitoring in terms of looking at real time, logging into the system and checking the current signal levels and fiber losses and anything else you wanted to look at and capture that over time, because what I just described won't capture those results over time. If you want to do something like that, then you need to set up a remote monitoring system where you're dialed in, constantly polling and grabbing the information from the system and the health of the system over time, so you can see, is my RF signal strength, either input power or output power of the system, is it degraded, or how has that changed over time? And so you do that via some IP connection in most cases. So it could be a wireless modem, it could be a direct internet circuit, DSL kind of line, or cable modem. But you need some IP connection to remotely monitor that from a central monitoring platform. So those are a couple different answers, I think.
And Scott, a question came in from the audience. How is the 90 or 99% coverage requirement tested? I know you went over in your presentation the grid test.
Yep.
And I know that's done with a person walking around. So the two different tests, one DAQ and one with a spectrum analyzer or other kinds of tests. Can you describe the actual physical process of each of those tests and how the results are recorded?
Yep, sure, I can do that. So this is actually something we were somewhat recently, it's been maybe a year now, we were certified actually by the FDNY, so the Fire Department of New York, for their ARC wireless system, so their auxiliary radio communications. And so, and a lot of municipalities, I think you need to be certified in order to perform this work. But being certified to do this testing and installation, so we've gone through the process quite a bit, especially with FDNY and their sort of definitely more stringent, I'd call them more stringent requirements. In my mind, and what we typically end up doing is you want to be ideally test as close to the same conditions as the emergency responders would be using. So in other words, and this is what they actually require in New York, and each municipality is going to be a little bit different. Again, it's a sort of the caveat to all these answers. So they require you to get the same radios that, the same, I forget what brand they are, but the same radios that the fire departments are using. So we, as a certified tester for that state, we actually have the same radios that the fire department has. We have the software to program them to the channels that are needed for each of the different municipalities. So you want to start with that. You want to test it as best you can. From that's the official way that they have us do the grid testing. And then for the grid testing, as the document shows, is that you divide the building into equal squares. I think they're 20 by 20 or 10 by 10 or whatever the code says. And in each one of those squares, you want to test signal strength from those radios, ideally, and you want to test. So you want to make sure you're meeting that neg 95 coverage. And again, the requirement is basically, I think you can only fail one square per floor or something like that. Whatever the requirements say, they're going to be very specific. But that's how you're testing to make sure you're meeting that 99%. At the same time, as well, when you're testing in that in each one of those squares, you're also doing this DAQ test, which essentially what we've done is you're actually talking to the dispatcher or someone at the other end and saying, you have to coordinate this ahead of time. You're actually saying, okay, can you, how is my speech? Can you hear me? And you're measuring and sort of documenting, is the speech perfect? Is it, noticeable without repetition? And you're going through that DAQ score, and you're scoring each one of those boxes as well. In fact, one of the things we have to do in New York is actually we have to record that and make that as part of our submittal, so that they have a record of this was the audio that was recorded in each one of the boxes. So that's actually a special requirement. So those are some of the things that the testing that we do and how we confirm the 99% and the DAQ level is by following those. And again, each municipality is a little bit different, so you need to make sure you verify that.
So an interesting thing about the voice test is imagine if you're walking from one square in the grid to another and you're using the same phrase, can you hear me now? If you use the same phrase over and over and over again, the person on the other end can predict what's being said. And so they may not really be making a good test. And so what's recommended is to use something called Harvard sentences. And go ahead and Google that. I won't explain it, but a variation on the idea of the rain in Spain is mainly on the plane. There are a lot of different sentences that could be used to verify that someone really does hear what's being discussed. But on the, if you're using test equipment, Scott, are you measuring the downlink and the uplink when you're using a spectrum analyzer, or just the downlink? What is actually being measured when you're using test equipment?
Sure. When you're using test equipment, you can do uplink and downlink. So again, the official grid test or the acceptance test is typically with from what we've seen, is typically with the radio. But you can, prior to that, we actually do testing to make sure everything's okay before we start this official testing and have the AHJ out there and all that other stuff. So you can measure at the donor antenna what your input signal is, and you can put a test transmitter there or a signal generator and broadcast back into the BDA, into the DAS, and have it provide coverage into the building. And then you can go and walk around with a spectrum analyzer and measure that. And that's the downlink. You can do the same thing in the uplink. You can you can say, okay, I'm going to measure from the output, or right where you at the top, basically where the donor antenna is. I want to measure the uplink transmit. So you can measure from a spectrum analyzer from up there, from various places within the building, to make sure your uplink is also meeting the same types of performance requirements that you're expecting. So again, you do this prior to getting out there with the radio and the handset to verify the system is working correctly and is designed and installed meeting all the specs.
And so many of these spectrum analyzers store the information. Alex, would you be able to take the information that was stored and bring it back into the design to kind of see how the real world performed against the design?
Yeah, definitely. That's one of the things that we could do. We also integrate with a lot of these vendors that Scott mentioned that you would probably use for collecting this data. And one of the things that we have on our software is we have a prediction versus measured data report that you could use, the heat map that you generated, right? And then import whatever walk test to kind of give you what the delta would be, and standard deviation and things of this nature.
Thank you. And so one of the things that I can help connect the dots between is how fire code officials, building inspectors, or AHJs, authorities having jurisdiction, see this process versus how we in the technical world see it. It's possible that we might do this test, this empirical testing before the building is occupied, because the purpose of the testing is to get a certificate of occupancy. From a process standpoint, many of the authorities having jurisdiction will issue a temporary certificate of occupancy, or a TCO, predicated upon retesting after the building is filled up with furniture and equipment, and in the case of a warehouse, maybe filled up with stock, or in the case of an office building, filled up with people. Scott, do you ever see a situation where an empty building is going to show different results than one later that gets all filled up?
Definitely. Yeah, there's definitely differences that you want to take into account. When we've done tests in those exact situations, when the building's just constructed and it's just a shell, you'd get different results from when then they put it in file cabinets and all these other things, desks and cubicles and all these other things they put in an office building. You're definitely going to get, it's likely you're going to get different results, different signal levels based on that. That's true.
And that certainly is true in a parking garage as well, if you want to test it in the middle of the night when it's empty, or in the middle of the day when it's full of cars, right? So right. We have just a couple of minutes left before we wrap up, and I'm grateful. We've had a tremendous participation today. The majority of the attendees stayed on for the entire call and the Q&A. Thank you for that. Just a reminder that we will be sending a copy of the presentation and a copy and a link to watch the webinar again. Final question for each of you. What are some of the most important takeaways from this for people to keep in mind to make sure that the way that it's designed is the way it functions in the real world? And I'll go to Alex first.
Yeah, John, like I mentioned earlier, I think the key takeaway for us, especially if we recognize how important public safety is, right? And a lot of times we have to get reminded by some of the events that we see in the news, but, to use tools to make sure that you're meeting those NFPA and IFC guidelines. So for me, that would be, the key takeaway. Use solutions out there like iBwave Design to make sure that you're reaching those requirements, right?
Thank you. And Scott, key takeaway for you?
Sure. I would echo a lot of what Alex said in terms of these are important systems. They're not to be taken lightly, and I think you want to make sure that my key takeaway is make sure that you have full monitoring and full visibility into what's going on, not just meet the minimum requirements, but if something else changes that not necessarily that's not listed on the minimum, the requirements for monitoring the system. But if something else changes, it really could impact coverage of the system. And if that happens, you will end up with another incident, like those unfortunate incidents that Alex was referring to. So we don't want to end up in that situation. Nobody does. So I think it's important to take these systems seriously and to do what you can to make sure they're working reliably.
Thank you so much. So this concludes our webinar, The Life Cycle of a Public Safety Network. Please visit us at saferbuildings.org for more upcoming webinars. I want to thank iBwave and C2 Systems for helping us put this fantastic session together. Alex, Scott, great job. We'll see you all on email afterwards with a follow-up, and take care, everyone. Have a good rest of the day.